Alright, so for day 2 of Unit 8, applications of trigonometry and inverse functions or inverse trig functions. Okay, we'll start with our general graph of our sine function, and we'll look at our general graph of our cosine function. Right, and we can say, hey, that the graph of sine and the graph of cosine are shown. Notice that if we draw a horizontal line, y equals b, right, that if we come over here and we draw a horizontal line, y equals b, right, across each of these graphs, right, and this horizontal line being between -1 and 1, then the horizontal line intersects our sinusoids many times, right? I have an intersection here, I have an intersection here, I have an intersection there, another one there, and I'd have these infinite intersections, right? With the cosine function, the same thing. You've got all these intersections. Okay? This type of situation is called many to 1, because many x values map to a single y value, right? Meaning that, hey, I have an x value here, I have an x value here, an x value here, an x value there. All of those x values all have the same y output. We call that a mapping. Okay? Now, in order to have a function whose inverse is also a function, recall that it is necessary for our functions to be, and we're going to say that this is for our functions to be one to one, so that each x value maps to only one y value, right? So how can we deal with that in this situation, that clearly this is many to 1 and we want to restrict it to be 1 to 1? Well, what we can do is to restrict the domain of the sine function and the domain of the cosine function so that their inverses will also be functions, right? That if I look at on the sine function and I look at just part of the sine function, right? I look at just this part of the sine function. Well, now a horizontal line will intersect this red section once and only once, regardless of where that horizontal line is, right? And we call that a horizontal line test. Right? Regardless of where that horizontal line is, I'll intersect this red section once and only once. So if I restrict the domain like that, I'll be 1 to 1. And similarly on the cosine function, I'll have it in a slightly different position, right? If I restrict it to right over here where we see this part in red, right, then I have this set up and I say, okay, well, horizontal line intersects that red section once and only once, right, then I'm going to be 1 to 1. That's a very important concept for this, okay? So we see these graphs drawn again. Here I have the restricted domain sine function. Here I have the restricted domain cosine function. All right? And we call these 1 to 1. Once again, I pass this horizontal line test. Okay? And it's important to understand that our restricting domain, the standard is going to be as follows, right? That if I'm working with the sine of x, I'm going to say that x needs to be between -pi/2 and pi/2, right? That if I restrict the domain like this, I will be 1 to 1. Okay? And for the cosine function, right, if I had y equals the cosine of x, then I would restrict the domain from here to here, right? Restrict the domain from there to there to be 1 to pi, which is that x is going to be between 0 and pi. That's very, very important. Okay? Then, more on our inverses. Recall that if f raised with the superscript -1, right, if this is the inverse of function f, then we have the following properties. A big property is that we have symmetry. In the line y equals x. So in other words, if I have some xy coordinate, it'll change to be yx coordinate. All right. Another way to talk about that is that the domain and range of one function becomes the range and domain of the other, right? So domain changes to range, range changes to domain, right? Same idea here. So what's important to realize is that, hey, if this is the restricted domain for my function, then this is going to be the output, the range of the inverse, right? If this is the restricted domain of the function, then this is going to be the output, the range of the inverse. Okay? And then finally, we can think of this as f undoes the inverse and vice versa, right? So in other words, that if I evaluate f at the inverse of some input, that's going to be the same as the inverse of f at some input, which will be that input, right? However, there is a huge caveat based on the restricted domain and the range that we are using, right? And we're going to see this example. Okay, so let us define this arc cosine of x to be the inverse of cosine of x, right? So then similarly, right, if f of x is equal to sine of x, then the inverse, we're going to say, is the arc sine of x, right? So we're going to define arc cosine of x to be the inverse of cosine of x, and if my function is sine of x, then my inverse I can define as arc sine. Okay? This third bullet point, this huge caveat of undoing, comes into play as follows. Based on restricted domains, restricted ranges. Okay, so the arc cosine of the cosine of pi over 3 is pi over 3. Why? Because the outputs of the inverse cosine function are between 0 and pi. Right? So, here's my input. It is between 0 and pi. My output between 0 and pi. Awesome. But if I look at this one, my input here, 5 pi over 3, right? Well, the cosine of 5 pi over 3 is the same as the cosine of pi over 3, right? That if we come over here, we consider, right, the quadrants that we're in, right? That in this quadrant, the cosine has a ratio of 1/2, 1 on pi over 3, and in this quadrant, the same ratio, right? However, 5 pi over 3 is not between 0 and pi. The output of this cosine function has to be between 0 and pi, so I cannot output 5 pi over 3. I cannot output negative pi over 3. The output has to be the correct output, in which case is pi over 3, right? That the range of the arc cosine is that restricted domain that we had earlier, right? That this restricted domain is the range for the cosine, and this restricted domain ends up being the range for the arc sine. Okay, so very, very important, right? That we restrict the domain on the function, it becomes this restricted output for the inverse. Okay. We're going to do a lot of practice problems with this, but that's the introduction. Make sure that you get your practice in and ask questions for clarification.